Okay, in this video we're going to give a rationale for learning and figuring out inverse functions. Inverse functions have the unique property that if you take a function and you put a one-to-one function that does have an inverse, and you put its inverse inside, it cancels it out and we get nothing but x. Same thing as if I put f inside of f inverse. If I take f inverse of f of x, I'll end up with x, okay? Now, we already use this principle, you just didn't know it. For instance, if I look at x cubed, call function of x equals x cubed, it turns out that the inverse of x cubed is the cube root of x. Okay, the cube root of x. And in elementary algebra, when we get a problem like x to the third power equals 27, what do? How do we solve this? Well, we take the cube root of the cube and it cancels it out, right? But you have to take the cube root of both sides. Okay. And this automatically becomes x, and the reason it becomes x is because we put f inside of f inverse and we get x, okay? And the cube root of 27, we don't know, we just say, well, that's 3. Well, we can figure that out, that's not hard. So in order to solve this, what we did is we took the inverse, f inverse of x cubed of both sides, and it canceled out our x. And so we got our answer. And this is how you use inverses. This is a very important use of inverses. Let's take a look at the function f of x equals 2 to the x. And we want to find f inverse of x. Okay? Let me give myself a little more room. I'll start over here. F of x equals 2 to the x. That's an exponential function, right? And we want to find f inverse of x. That's what we're after. I wonder what f inverse of x is. Well, typically the way you find an inverse is you call it y. You call f y, and you say, well, y equals, not very clear, is it? Excuse me. Y equals 2 to the x. And then we switch the ordered pairs and we say x equals 2 to the y. Okay? And then we solve for y. Well, you can't solve for y very easily. And so what mathematicians do when they can't do something is they say, well, I know that y is the power to which I raise 2 in order to get x, so I'll define it that way, and I'll make up a name. I'll call it y. F of x equals log, and that's log. Let me get a nice, it's not writing, log. And then I can't really have enough room. I'm going to move it over. F of x, f inverse of x equals the log, L-O-G, of x base 2. And we define it as the log as the y, the power to which I raise 2 to in order to get x. Now I've got an inverse, okay? And f of f inverse of x is going to give me x, and f inverse of f of x is going to give me x also. So here's what happens. If you have the same base, then f of f inverse of x equals 2 to the log of x base 2. That equals x. So they cancel each other out. Likewise, f inverse of f of x, okay, which equals the log, here's f inverse is the log of base 2. It's the inverse of 2 to the x, see, of 2 to the x equals x. And that allows us to cancel those out.